Hey everyone! Thanks for joining us for the next session of our Python and AI Level Up series on tool calling. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter and moderator to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today. Pamela, thank you so much for joining us.
Hello, everyone. Welcome to week 3 of our Python plus AI series. We have had a lot of fun. We've covered a lot of topics so far. We are on our 7th class today, our final week. We've already covered 6 topics, 6 classes. If you miss any of those, you can catch up with the recordings, the slides, and the code samples with the link that we can put in the chat, which is our aka.ms/pythonai/resources link. Everything is always available for you to catch up and learn whenever you need to learn. Now we are in our final week of the series, and this week is all about tools, agents, and MCP. So really, you can think of it like this week is really all about tools, because all of those are about tools. Like, how do we give our LLMs the ability to actually do things, to call tools that will make them more useful and more powerful? So we're going to be looking at that all throughout this week, with these different classes. And these are some new topics here, like agents and MCP. Those are, pretty new in the last year. So it should be pretty fun this week. So today we're going to talk about tool calling, which is the basis for really building agents and also, really related to MCP as well. So this is it's a topic that's really important to understand, even if you end up using an agent framework to handle all your tool calling for you. But it's always really important to understand the foundation of what you are using. So if you do want these slides, you can grab them from this URL here, and you can share them. You can teach this class yourself, whatever you want to do with them. So here's what we'll be covering today. What is tool calling? How do you actually use it step by step in Python? How do you use multiple tool calls, both in parallel and in a loop? How do you improve tool calling, especially with local small language models? And what are some scenarios that we use it for? If you do want to follow along with the code today, you can open this GitHub repository. This is one that we've used earlier in the series as well. If you already have it open, what you should probably do is run git pull in order to get the latest updates, because we do update these repos through the series with new examples. But if you haven't used it before, what you do is you click on it, and this goes to the GitHub repo, and you'll see a code button here, and it has a local option for checking it out locally, which you can do if you want. It requires a little bit more setup in a good Python environment. But what we recommend for most people is use the code spaces option, because this will just work, and you can run all the examples for free using GitHub models. So I'm going to click create code space on main. And what that does is sets up a code space in the browser. So this is basically VS Code embedded inside my browser, and it has the project open. It has all the Python set up. It will have all the Python packages installed, everything that we need to be able to run these examples. So it'll take a few minutes to set up, and boom, it's already set up actually. And then we should just be able to run these examples without needing to do any extra work. So that's what I recommend if you want to follow along. You can also do that later after the session. So let's just briefly review, how do we call a large language model from Python, right? So here we have chat.py. This is our basic, hello world here, right? And in chat.py, we can connect to different hosts. We can connect to Azure. We can connect to local models with Llama. We could connect to GitHub models. That's what we use by default since they're free in code spaces. And we could use, an OpenAI key. So first we connect to our model provider, and then we make a request to the model here, right? So we say, okay, this is the model we're using. This is the temperature. And here's our system message. So you're a helpful assistant that makes lots of cat references and uses emojis. And then here for my question, I'm asking, what is the weather in SF today? So let's see, what is it going to say if I ask an LLM, what is the weather today? Does it know? Let's see. So now what it's doing is going off to the connecting to the model, and in this case, it's using GitHub models. Let me show you GitHub models if you haven't seen this before. GitHub models is a marketplace of models that you can use for free for up to a certain rate limit each day. So these are the ones we're using. So here we go. It has responded. It says response from GitHub models. Oh no, I can't fetch real-time updates for you, friend. But you can always check a weather app for more precise info. The puns are horrible. Okay, so as you can see, when we ask an LLM what the weather is, it doesn't know, which is good because it shouldn't know that information. That information is nowhere in its weights because it got trained at a certain point in time, and there's no way that it could ever know what the weather is today just based off its neural network weights, right? So what can we do? We can use tool calling. So what is tool calling? It is a way that we can give the LLM the ability to suggest functions to call, right? So, in that example, we saw it generated text, but with tool calling, the LLM is going to generate a function call. And when we say a function call, we mean the LLM is just going to say, hey, here's the function name you should call, and here's the function arguments. The LLM is not going to call the function itself. We are going to do that. All the LLM do is say, hey, based off some functions that you say exist, right? It's trusting us, whatever function definitions we send to it. It's like, okay, you said there's a get weather function, so I think you should call it. And then I think you should, pass in this argument Paris, right? So it's just suggesting what function should be called. And then in our application code, we are actually going to call that function, right? But what's helpful about it is that, the user is going to enter some free text question, and the LLM can figure out based on that question and based on the functions available, like, which functions would actually help us answer this question. And so once we have tool calling, we can handle user questions in a much more structured way. It's easier for us to bring in tools, APIs, databases, just any sort of programmatic logic that could help us to answer a user's question better. So here's the basic function calling flow. This diagram is from the OpenAI docs, but basically first, as the developer in our code, we tell the LLM, hey, here are all the functions you can possibly call. Here's each function name, and here's the arguments. We don't tell it the actual function code. We just say, here are the function names and the arguments that they take. Then the LLM sees the user query and says, oh, okay, based off those function definitions and the user query, you should call this function with these args. And then we, as the developer in our code, we call the appropriate function based off what the LLM says. So let's actually see how we implement this in Python. So the first step is to tell the LLM what functions it can call. One way to do this is to actually write out the JSON schema for the function. So what you see here, this is called JSON schema. It is a way of describing describing the, a function and the arguments it can take. So we say, okay, it's a function. It has the name lookup weather. It has a description, lookup weather for a given city name or zip code. It has the parameters that it takes. It takes a city name, which is a string, and it takes a zip code, which is also a string, right? So we write out this JSON schema here. And then when we make a request to the model, we also pass in our function schemas, right? So you can see this actually looks very much like the request we sent earlier. The only difference is that now we're passing in this schema of tools in this argument here, right? So let's actually try this out. Function calling basic, right? So here's our schema here for the function. So you can see we're just giving a schema. We're not giving an actual function. We are just giving a schema. That's all that the LLM needs, is basically the name, the description, and the arguments. So then we're going to pass it in. And this time we're going to ask, oh, what's the weather like in Berkeley? And let's see what happens here. So we go out to the model. And this time when we get back the response, we check to see if the message has a tool calls array in it. And if it does, that means that the LLM is telling us what tools it thinks it should be called, instead of just giving us a free text output, right? Because before we just outputted message.content, but now we're checking to see like, oh, hey, is the LLM suggesting tool calls? Okay, if so, let's look at those tool calls. And let's look at the name it's suggesting and the arguments. So here we can see the name is lookup weather. And the arguments, it's suggesting city name and Berkeley, right? So based off the user query, it said, okay, I see this user query. I see this function schema. I think that we should call this function, right? That is what the LLM is doing. It is not calling it. It is not actually calling the function itself. It's just suggesting a name and an argument, right? So if we change this, right, we can be like, what's the weather like in SF? And rerunning this, it's going to say San Francisco. And you can see it even expanded SF to San Francisco, right? So one nice thing is that, the LLM can kind of clean up our arguments. It's also making assumptions, right? It assumes SF means San Francisco. And, even though like maybe somebody else might think SF means something else. I don't know what else it can mean. We could also like say, Clima. Right, we could do some like Spanish, right? So we get multilingual support out the back, right? So here, once again, look up weather Seattle. So you can see this is much better than, in the past, if we were trying to do something like this, we would probably use like a regular expression and try to figure out like, oh, the person's trying to ask for weather. And here's the location I think they're trying to ask in, right? This is much better than using regular expression, right? We're extracting out what is that their intent, what the user like wants to find out about, and the actual arguments we want to pass in. So we get back the suggestion for what tool to call. So that's the first step, is just getting back the function name and arguments. Right? So we get those back and then we see, okay, the LLM thinks we should call this function with these arguments. The next step is to actually call a function based off of that, suggested name and arguments, right? So that's in function calling call, right? So in this one, we have actually implemented this function locally. So we've got lookup weather. It can take a city name or zip code. And this one, it's really basic. It just says, what it's been called with, and it's always sunny. Now, if we were going to actually do this, we would replace it with a call to a weather API that would do this lookup, right? But then we still have the function schema here, right? Because this is what the LLM is going to look at, right? The LLM does not actually look at the code of the function. The LLM only cares about the description of the function, its name and arguments. All right, so now when we're going to call it, and this time when we get back the name and the arguments, we're going to say, oh, okay, does the function name equal lookup weather? Then we're going to call lookup weather with those arguments, right? So remember the argument was it was a dict, like what was it, city name Berkeley, right? So That's basically what the arguments were, right? And so in Python, we can use, this is the best name. This is called the double splat operator. So we're going to use the double splat operator in order to turn this dictionary of arguments into the actual arguments for this function, right? So what that actually becomes is, it's as if we said city name equals Berkeley, right? So that's what's actually happening here, right? We get back this dictionary of arguments, and it's actually a JSON, serialized JSON. So we have to turn it into the actual, from a string into a dictionary. Now we got it as a dictionary, then we can double splat it and pass it to the function. And I see there's a question there about like, how do you know how to write this, this schema? So this is a standard. Let's see, JSON schema. So there is a standard here. You know, I've actually never even looked at this doc, because what I always do is just start with an example. And probably I went from the OpenAI function calling docs when I was learning it, right? Defining functions, right? So here you can see an example. But it is a standard, the JSON schema standard, but it's good to check the actual documentation to see what sort of things are supported, right? So here it says what you need. You need type, name, description, parameters, and strict. And the parameters is what follows the JSON schema. Now, most of the time, we're actually going to use a framework to generate the schema for us. We're only having to write the schema ourselves right now because we're using the OpenAI package. And so this is fairly like low level. But tomorrow, when we do agents, we'll be able to use the agent frameworks in order to just turn Python functions automatically into JSON schemas. So a lot of the time when you are using function calling, you're probably doing it with an agent framework. And in that case, you'll be able to just write your function, and behind the scenes, it'll turn it into this. But I like to show you what this is what's actually happening, right? Like, for whatever, function that we're defining, this is what we're passing to the LLM over the wire. All right, so now we've called the function. Okay, so that's the next step. We've called the function. So then, and we could stop there. I like showing this step by step, but because I have various projects that will just stop at each of these points, right? Because sometimes I use function calling just basically as a way of extracting a structured response, and then I just use those however I want. Sometimes I do what I just showed. I'll just show the function, and then I'll move on to something else. But you can go farther, in that you could actually then send the LLM the results from that function and send the full conversation to the LLM, and the LLM will finally answer the question, right? So this would be like the full flow here, is that we call the function, we get back the response, we send the response to the LLM, so the LLM can see, oh, okay, I said you should call this function. Now I can see the response you got that from that function. Now I'm going to respond to the original question. So let's see how that is implemented. This is in function calling extended.py. So here we have our function again. It got slightly fancier. It's returning a dictionary now. Here is our schema from before. That's the same. I'm asking, is it sunny in Berkeley, California? I get back the response. So if it says, if it suggests the lookup weather function, then I'm going to call that function and get back the results. And then I am going to append this message to the conversation. So first I've appended what the LLM responded with. And, that's the one where it said, oh, we should look up weather, with some args, right? Then I actually call that function and get back a response. And so then I append and say, okay, this tool gave back this content. And I stringify the result there so that it'll accept it. And I also have to reference the ID of the original tool call here. So I get that from this original response. So I append that to the conversation. So now this conversation has multiple messages, right? It has a system message, it has the user message, it has the tool call message, and then it has the tool response message. So there are 4 messages in this conversation. Then I send these all to the model, and then the model will respond to the original question here based off the tool call response. All right, so let's try that out. Okay, so it says, yes, it's sunny with a temperature of 75 degrees, right? So it did that based off of what came back here, sunny, 75, right? All that came back. So there we go. So that would be the like full flow for calling a single function, sending the results to the model, and getting it to answer the user's original question. Now, let me just check to see if any questions, just because I know there's often questions about tool calling here. So let's see. I see a question. Is it possible to include rate limiting on tool calls? So that's a great question. If you can do rate limiting on tool calls, I mean, you can implement anything you want in this function itself, but what you probably mean more is, can you limit the number of tools that your LLM can call? And that is actually something I do when I'm using agents. And I've got a middleware basically that I write for it, that I say like, that I put between the agent and the tool calls. It says like, listen, if you've gone past, like 10 tool calls, you just got to stop now. You're done. I'm cutting you off, right? So certainly you can implement that kind of logic to say like, okay, listen, you've done too many tool calls. This becomes relevant once we add in more tool calling. But yeah, very commonly I will implement some sort of middleware to say, hey, you've gone past the number of tool calls. So I see the question from Leo. How do we know when to initially call a tool? So we don't know. We're asking the LLM to suggest when to call a tool, right? We're saying, hey, LLM, here's the user's question. Here are the tools. And it can choose either to answer the question or to call a tool. Now, okay, for example, what if we asked a completely different question? What is 2 + 2, right? This is a question where it should not need to call the tool, right? Because we haven't given it a calculator tool. Oh, so in this case, it decides, because probably in this case, I don't even have an else. So let me get an else here. Okay. All right. There we go. 2 + 2 = 4, right? So it is up to the LLM. If I ask what is 2 + 2, and the only tool I gave it was a weather tool, it's not going to call that tool because it's not going to help it answer the question, right? But as soon as I ask, what is the weather in Seattle, then it's like, oh, okay, well, I see there's a tool that can help me answer this. Let me call this tool instead. So we're letting the LLM decide based off the tools and based off the user query, like, hey, which of these would be appropriate to call at this point? And if the LLM suggests a tool that, we know about, that's in our code, and that's all it should suggest, because it should be based off function definitions, then we're going to go ahead and call it and send the response to the LLM so it can make a more informed answer to the original question. All right. Okay. So now let's keep going and talk about how to handle multiple tools. That's when things get really interesting. And that's fairly practical. There's many situations where you potentially want to give the LM different tools it can use to answer the question, right? So there's 2 general approaches. The first approach is one that only works for some models, for some providers, right? So this is called parallel tool calling. This is supported by OpenAI, but there are some restrictions as to when you can use it. But parallel tool calling means that the LLM will actually, in the same response, will tell you multiple tools that it thinks should be called. So it's going to look at this question, right? and say, okay, well, based off that, which things, which functions I call. And sometimes it might call multiple, right? So I think, let me look at the actual example. So function calling parallel, right? So this is the better question to trigger both questions. Is it rainy enough in Sydney to watch movies, and which ones are on, right? So this question here is a complex question, and it's one that could be answered by using multiple tools that are available. Because here what we've got is a lookup weather and lookup movies. So we had the lookup weather from before, and now we're adding the lookup movies, and we've got implementations down here. And as it turns out, this question would best be answered by calling both of those functions. So we can give those to an OpenAI model and see, and it may actually suggest calling both of them at the same time. So let's see if it decides to call both of them. We're going to ignore that. Okay. So it in fact did, right? So we can see here that it says that it suggested two of them, right? It said it suggested two tool calls at the same time. And so what I'm going to do is actually use this is a Python thread pool executor. So I'll use this in order to actually call my local functions in parallel as well, right? Just so I can get, the best performance about, calling two functions at once, right? So the LLM says, hey, call both these functions. I'm like, okay, I'll just call both of them, and I can call them both in parallel, and then get back the responses to them. And then when I get back the responses, I'll add each of the responses to the conversation here. And so now in the conversation, there's the system message, the user message, the response that suggested the two tools to call. And then there's responses from each of those tools. So there's two more, one from each tool. And then finally, we send that whole list of messages to the LLM and say, all right, we called those two tools that you recommended, and what do you think the answer should be, right? So there we can see that it says, okay, it is rainy in Sydney, so it's a good day for watching movies, and here are the movies currently playing in Sydney. So that is called parallel tool calling, because the single call to the LLM is recommending multiple tool calls. Now, the thing about this is that it is not there's many models that support tool calling, but do not support parallel tool calling. So many models will only ever suggest a single tool call in a response. And so you need to keep that in mind when you're working with models in terms of, what to expect from them. Now, fortunately, there is an approach that you can use that'll work across all the models that you don't need parallel tool calling for. So this is tool calling in a loop. The idea here is that we're going to use a while loop, and we're going to keep on calling tools recommended by the LLM until the LLM stops recommending tools, right? And this is how many of the models support tool calling, is that if they realize that they need to call multiple functions in order to answer a question, they're just going to figure out the order, and first, they'll recommend the first one, they'll get back that response, they'll recommend the next one, they'll get back that response, they'll recommend the next one. So this takes more calls than the other approach, but it does generally work across more models. So let's check out that example. That's function calling while loop. So here, once again, we've got lookup weather, we've got lookup movies, and we've got the implementation here, lookup weather, lookup movies. And I'm asking this same question, but this time I specifically turned off parallel tool calls so that I can demonstrate this to you with OpenAI models. So I said, all right, this time don't use parallel tool calling. And so we're going to get back a single tool call, and we're going to call them. And I did use a for loop here, just in case we got multiple tool calls, but this isn't necessary, right? Because we're only going to get back a single tool call each time. We're going to call that tool. and we're going to append it to the conversation and then go back to the top of the while loop and call the LLM again. All right, so let's try out this one, right? So you can see it calls the model. The model says, all right, look up weather, right? So it only suggested a single tool call here, right? It said you should call look up weather. So then it's going to call the model again. And this time it said, okay, now you should look up movies. And then it's going to call the model again, right? And what you can see is we end up getting basically the same response. It just took a few more model calls since we needed to go back another time in order to find the next tool to call. But the nice thing here is that the LLM is either going to give us back a tool call, or if not, it's going to give us back the answer to the question. So you can basically have logic like this. It says, okay, if we didn't get back a tool call, that means the LLM decided it can answer the question. So I'm just going to output its response and then break out of the loop, right? So basically, once you realize you have no more tool calls to process, that's when you know that the conversation, like the request has been answered, the LLM has given back its full text content, and we can break out of the loop. And so there we go. So I see a question: the question is the data generated by the tool sent back to the cloud model? So yes, it is. So it's sent back here. So see how we get back the tool request. So we get back the function name and the arguments. Then we call the tool with the arguments. Now this is looking a little crazy here. It's a little hard to read. Target tool we got from this tool mapping here. So see tool mapping, what we did now that we have multiple tools is I mapped them internally and I said, okay, look up weather is this function and look up movies is this function, right? So I get back the right function and then I double splat those arguments. So we're using that to call the tool. We get back the result. We turn it into a string so that we can store it in the message conversation. And then we append that message to the conversation. Now, this is my opportunity to remind you that if you are wondering what is sent to the actual model, what you're going to do is do import logging and then logging.basicconfig, set the logging level to debug, and then rerun. So when you are using the OpenAI package, this is going to show you everything getting sent to the model. So let's see. Let me see. Okay. So you can see this is the full conversation here. It's a little hard to actually, read this, but let's see if you can see here. There's all the tool call responses, right? So here's for example, this is the response to the lookup movies function. So this has the actual movies. This is the response to the lookup weather function that has the actual weather, right? And so all of that gets sent to the LLM. So if you're ever wondering what actually gets sent to the LLM, just turn on that debug level logging and you're going to see the matrix. You're going to see behind the curtain and see what is getting sent over the wire. I also see a question: what if the tool generates a lot of data? Yeah, that's a great question there. So you can, with these larger models, we do have context windows between 128,000 and even 1 million for some of them. So you can actually send a fair amount of context to a model, but there is a nice best practice is to only send summaries back to the model, right? So if you do get back a very large amount of data from a particular API or call or something like that, you may want to actually use an LLM to summarize that and only send that back to the model. That's a more advanced technique that you can use when you get to that, when you reach that problem, right? If you're seeing I'm blowing up the context window, I'm sending too many tokens, my LLM can't handle it, I need a better strategy. A very common thing to do is to basically summarize what you're sending along so that it doesn't have as big of context, right? But I wouldn't worry about that until you actually have that problem. All right. So that's tool calling a loop. And the thing is, this is this is kind of a lot of code, and it looks a little hairy. And the thing is, if I am going to be basically doing tool calling in a loop, that's when I'm going to use an agent framework, because agent frameworks, basically make this a one-liner. So tomorrow we're going to see, how to do all of this code here with much, much, much less code, thanks to agent frameworks. However, I like to show you how you can do it with tool calling, in case you realize you need more control and you want to implement it yourself. And just so you understand what's going on behind the scenes of agent frameworks, right? You can imagine a lot of them basically have code very similar to this. I just don't want everybody leaving today thinking that, you should all have this code in your, your own code bases, because you can certainly use libraries and frameworks that will abstract on top of this and make it much easier for you. All right, so now let's talk about support for tool calling. And I've seen a lot of questions about this in the chat. So OpenAI was the first LLM provider to support tool calling, but so many other model providers added support for it because it's just so helpful. So it's now almost like a standard thing that you should expect out of most models, is to have support for tool calling, right? So OpenAI has it in basically all the current GPT models, plus O3 Mini. It's in the latest GPT-5 models as well. So, going forward, we should expect it in all OpenAI models. On GitHub models, we have it in quite a few of the non-OpenAI models too, right? So Jamba, Mistral, etc. They all support tool calling. Azure AI has all those models and many more. And then Ollama also added support for tool calling to some of their models too. So you can actually look at their catalog specifically to see which models support tool calling. So technically, many models do support tool calling, but there's varying levels of support. And this is something that I've had to deal with a lot practically when trying to make other models work with tool calling. So what can happen is that if you use a model that doesn't have as strong support for tool calling or as strict support for tool calling, you can get hallucinations, right? So you might have it suggest a function that you never even said existed, right? Like maybe it could make up one entirely, or it just gets the name wrong. What happens even more often is that it makes up the arguments, right? A lot of times it's easy for it to figure out the right function name, but it can struggle with arguments if they're more complex. And like if it's trying to accept like a dictionary and it just doesn't know how to make that dictionary. So that's what I see the most often, especially with the local models with Ollama, is that this tendency to make up arguments that are not in the right format, right? Just because these local models are not as well trained, they don't understand JSON schema as well, and they're just more likely to generate incorrect formatting. The other thing you can see is that you might give it a bunch of functions and say, hey, call these functions, and the model might not choose the function you want it to call, right? And you'll put everything in your prompt, like please use this function when you see XYZ, and the model just doesn't call the function. And that can be really frustrating. And that usually happens for models that, technically support tool calling, but weren't trained with tool calling. So they don't have that, instinct. We'll call it instinct. They don't have that instinct to call tools. And so you end up having to beg them to call tools. So that can happen. What I've also seen a lot is that there's many models that support tool calling for a single tool call. So you remember this first example, here, just with a single call, like this one, there's many models that can handle this. But then as soon as we go to this function calling in a loop, they go off the wires, right? I have seen such wild hallucinations when I do tool calling in a loop with the local models in particular. It just gets crazy. It is so wild. So this is something to keep in mind, especially if you're trying to use tool calling outside of the models where it was really well trained for it. There is a tool called Leaderboard, so you can check this out if you like looking at leaderboards. Always keep in mind that leaderboards, they give you some information, but also they can easily be gamed. And what's most important is whether something works for your use case, right? So you can look at the leaderboards to get an idea for what the level of support might be like, but what you really care about is it going to work for the model you're using and the scenario you're using it in, right? So how do we improve reliability? After I told you, like, okay, there's can be issues, how do we actually improve it, right? So for the OpenAI models, and only for those models, there is a strict mode that you can pass in. And if you say strict mode, then OpenAI itself will guarantee that the result complies with the function schema. So I've already got that enabled in a bunch of the examples in the repo. So we've already actually been using strict mode. And so that's really helpful. So you should always use strict mode if you can. There are some restrictions about it. So you definitely want to check the OpenAI docs to learn about the restrictions with it. But if you can use strict mode, great. You should do that because it'll give you, higher degree of confidence in the results that come from the models. Now, if you can't use strict mode, right, you're using it with some other models, then what you really need to do is make sure that your code has error handling. You have to get ready for every possible thing to get wrong, right? So for example, you want to check, the function, does it exist, right? Has it suggested a function that exists? If not, then you're going to, give back an error. Oh, there I have my Spanish error. You can do that in English too. Second thing is, are the arguments correct, right? As saying, this is what I've seen happen quite a bit, is that the arguments aren't correct, right? So it'll format it incorrectly. It'll make up arguments. So you need to do basically exception handling there to see if you're able to call that tool with those arguments, right? And if not, what you do is you can give feedback back to the model and you can log it in your system. Here's the interesting is if you give feedback back to the model about what went wrong, sometimes the model can correct itself, right? If you're running in a loop, if you give it back feedback that, what went wrong, sometimes the model will correct itself. Now, it's annoying because that means you're having to call the model over and over. So it's not a great thing to have to rely on all the time. But it is true that if you're doing it in a loop and you give back feedback to the model, models will sometimes figure out the right thing to do. All right, so let's check this out. This is function calling errors. So first, I'm going to show it in with OpenAI models where it's not going to have any errors. All right, so let's try this out just to see what it looks like correctly. So this is one that has a schema that's a bit more complicated than what we've seen. This is a function that I use for searching a database, and it's searching a product database. And it can take in a simple string search query, but also a price filter, which is actually an object. And so this is more complicated because I'm asking for it to pass in an object that has a comparison operator and a value. So this is a more complex function to call because the arguments are complex types. However, OpenAI models do great with this. It says, okay, we're going to search the database. We're going to pass in this price filter. It's going to be this dictionary with this comparison, less than equal, value 20, and here's the search query. So this is perfect. This is exactly what I wanted to happen in terms of calling this function. So then we do it, we call it, and we get back a shirt. All right, so that worked great. Now let's go local. So local, I've got Ollama running. And I've got a few different models running here, right? And they're much smaller than the OpenAI models, right? So this one is 8 billion parameters. And so now I'm going to open up that errors and see how it does. So let's see if it can, if it's going to come up with the right arguments this time, or if we're going to get an error. All right, so we're doing Llama 3.1 on Ollama. And it's, of course, it's slower because my machine is not that powered. Okay. So this time, what you can see is that it got the function name correct. However, this argument is incorrect. You see how it says, let me make this bigger. It's saying the args is max price, min price. that is nowhere in my function definition at all. This should be comparison and value. So it hallucinated max price and min price. It knew it was supposed to be a dictionary, but it completely made up max price and min price. That is the kind of thing that I see with these local models on a llama all the time, right? So, so when I did a call, then, I basically said tool execution error. And so then the LM said, oh, it looks, it blamed my tool. It looks like the tool has a bug. No, nah, you got a bug, fool. No. So anyways, you need to decide how you're going to handle those errors. And, whether there's some sort of recovery that you can do. Like sometimes I'll have like a fallback where it can just use, like in this case, we could just fall back to just the search query because it's more likely to get that correct because it's a simple string. So you had to figure out what your approach is going to be, or maybe you're just going to decide, well, listen, we're not getting good tool calling success with this model, so we're simply not going to use this model, right? Oh, I saw a question about GPT-OS. I do have a GPT-OS endpoint. Is this my one that's running right now? I'm not sure if this is the one that I have that's running right now. Let me see. We can try it with GPT-OS. I don't think this one's going to run. Oh, okay. Actually, here we go. Let's see. I think that in this case, I feel like it hallucinated the entire response, but maybe let me just see. Actually, I'm curious. Did it actually? Yeah, it hallucinated the whole response. It didn't call a tool at all. And instead it just gave back the content and it made it up. So that can happen with models as well, is that they can choose not to call the tool and make up the response. In defense of GPT-OS, it is better to use what's called the responses API versus the chat completions API. This is the chat completions API, but GPT-OS was designed to work well with responses. So if you do want to get a bunch of examples of GPT-OS doing tool calling, check out this repo here, because I had a live stream yesterday, and we have another live stream today specifically about GPT-OS with tool calling and agents. So if you're interested in GPT-OS, check that repo and come to the live stream in like 2 hours or so, I think, to hear about that. Okay. So there's error handling, and that shows you what kind of errors happen with those llama errors. Now, one thing that I did to make it to make my tool calling work better with these local models is that I added few shot examples. So I actually, made up what a successful tool call would look like and put that into the conversation. So here, if we go back and we look at the few shots example, what we can see here is that I have these example questions, right? So we say like, okay, if the user had asked this question, then, this is what you would call here, right? If the user had asked this question, this is what you would call here, right? So I'm really, really trying to help the model out by giving it examples and hoping that's going to help it deal with something, a new query, right? So let me change back to our local model with Llama 3.1. And we're going to try the same thing. Find me a red shirt under 20 and run this example here. And we are running that on Llama 3.1. So this time we got it correct, right? So remember before it made up the max price, min price. This time it did comparison operator and value. And that is what I've defined in my schema, right? So here, this is what we wanted. We wanted comparison operator and value. And that is what we got. And so it was successful. So that is what I found with the local models, is that it does help to give it examples of exactly what the what arguments would look like for related queries. Now this is going to increase your the amount of tokens you're sending the model, but it's by a pretty negligible amount, at least for a single function. Obviously, if you have lots and lots of functions, then this could get really overwhelming. But I did want to share this tip because it's basically the only way that I successfully got these small models working reliably with function calling. I see a question. Which models do you suggest running locally for tool calling, and which specs do you suggest for a Mac M4? So I do like the Llama 3.18b. As you saw, like it did have hallucinations, but it still has worked better for me than other models. You could also try Quen and Gemma. I believe both of those have support for tool calling. But I think for all of them, you are gonna get better responses when you add in the few shot examples. Generally, that's what I'd recommend, is checking those. And for specs, just get something more powerful than what I have. So I have 16 gigabytes of RAM. I think you definitely want more than 16 gigabytes of RAM. Try to get at least 32. That seems to be the difference for a lot of people between being able to run GPDOS and not being able to run it locally. I see lots of questions about the stream that's coming up in a few hours. So let me get you a link to that. Here we go. This is part of a series that we're doing with NVIDIA. So check that out. So that'll be, I think in 3 hours. And we also have a version for APAC in like another 12 hours. And then we'll have some more in November. So that shows you how to run GPDOS on an Azure serverless GPU with tool calling and agents. All right. Now let's talk briefly about evaluation. I was talking about when we're doing tool calling, we want to make sure that it's working well. Well, how do we actually make sure that it's working well? You can do all these, manual tests with the models to see how they're performing, but you can also do actually rigorous and automated evaluation so that you have some metrics that you can, report and say like, okay, for this model, we're, seeing these sort of, success metrics for tool calling. So the general approach when you're evaluating tool calling, and also when you're evaluating agents, because really agents are LLMs calling tools, is that you want to check both low-level metrics and high-level metrics. So like when I say low-level, I mean, was the correct tool called, and was it called with the correct arguments, right? And that shows you how the LLM is handling the really fine-grained steps of the process of tool calling. And then you also want to have high-level metrics, which is just, okay, was the response from the LLM correct for this user query, right? So that's kind of like an end-to-end evaluation, which is like, there's the user query, it got a bunch of tools, was the LLM's response correct for that? So it's good to have those end-to-end evaluations because that, shows you just overall how your system is doing, but it's also helpful to have tool calling specific, more fine-grained evaluations so you can identify what is going on wrong in the system, right? Like, is the problem that it's not calling the correct tool, or is the problem that it's calling the correct tool, but with the wrong arguments, right? So you really want to know that so that you can figure out what you need to improve, right? Like you might realize you need to put something in the prompt to remind the LLM like, hey, you should, call this tool for XYZ. Or you might have to give some better examples of what arguments to use, right? But the first step is to know where the problem is so that then you can make the right fixes for the problem. We do have an SDK that you can use for evaluation. It's called the Azure AI Evaluation SDK. We did show it in our AI quality and safety talk for those of you who are at that. And it does include metrics for evaluating tool calling. You can also find very similar metrics in basically all of the SDKs that support evaluation. You're going to find really similar approaches and really similar metrics, right? So from our SDK, the Azure AI Evaluation SDK, there is a tool call accuracy evaluator that is an LLM-based evaluator that will return a score of 1 to 5. So you pass it the user's query, the response from the LLM, the tool calls that the LLM made, and then the tool definitions. So then you're passing that to another LLM and saying, hey, LLM, look at this interaction and these tool calls, and decide, was that the right call to make, right? And then it'll give a 1 to 5 to say, 5, yes, that was perfect, right function name, right arguments, or 1, like, no, that was completely irrelevant, right? There's some other evaluators that's in the SDK. So there's the intent resolution evaluator to see how well the system understood the user's intent. And then there's task adherence, and that's more of the end-to-end evaluator, which is, according to this task, did it do a good job, right? And the thing about these evaluators is they're good for evaluating tool calling and also good for evaluating agents. So keep that in mind for whatever you're building in terms of evaluation. Now, in terms of use cases for tool calling, one big use case where I use it is RAG. So we, use it for getting a better idea of what to pass to our search index. So I'll talk briefly about that today. But the big use case is agents. Like agents are basically wrappers around tool calling, right? They are an easier way to call multiple tools in a loop and to, be able to do that in an easy way. So that is what we're covering tomorrow. And that's just, that's just tool calling to the extreme, right? But we can look briefly at the RAG use case, right? So this is, the example here is from the RAG on Postgres demo. So here, right, we've got some example questions. So some of these are like easy questions, right? If we say like best shoe for hiking, and we're searching a Postgres database and we get back some answers, and there all we have to do is search for hiking shoes, right? And then we'll find back, we'll find good responses back. And so when we search the database, we just say, yeah, show me some hiking shoes, right? That's an easy query. Now, if I have a harder query like this one, climbing gear cheaper than $30. This is a harder query because we don't actually want to search the database for just the string $30 because that's not what we're looking for, right? We don't want the string $30. We want to know which rows in the database have a price that is less than $30. So what we want to do, since this is a SQL database, is we want to search for climbing gear and then filter by rows where price is less than 30. So what I do here is I use function calling in order to say, hey, take this user query and suggest the function that I should call with what search query and what SQL filters it should have, right? And so what it does is say, okay, I think you should call, use the search query climbing gear, and then the filter, let's make this really big. The filter is price less than 30. And so I turn that into a SQL statement, right? So select from the columns where they match climbing gear and price is less than 30. So I really like using function calling as a way of extracting better queries for searching a database when doing RAG, right? So we call it, we get back the suggestion, and then I can turn that into a nice SQL query. And so, this is what the schema looks like. And we actually saw this schema because this is what I used for the error handling example here. And so then when, we do this full flow, right, we get back this structured information from the LM and then use that to search the actual database. So we use that in the RAG on Postgres. We also use something similar in RAG with the AI search. So generally, if you do have a RAG application, you might bring in tool calling as a way to extract a bit more information from the user query to help you build a better search query for the database. As I said, really where you're going to see tool calling shine is with agents. So you should join for tomorrow's session about agents, where we're going to go into many agent architectures and how to build agents with Microsoft Agent Framework. We're also going to see a bit of LangChain as well. In fact, LangChain V1 just dropped today. So we are also having another live stream tomorrow specifically about LangChain V1. So if you are interested in agents, you should come to the LangChain V1 stream. You should come to the agent stream, and you're gonna, see all about agents. You could also come to the NVIDIA stream today. Like, you'll know how to build agents, with all sorts of different frameworks and models over the next, 12 hours. So I'm sure there's many questions that I missed. Thankfully, this is wrong. This should be Tuesdays. Today is our office hours. So what I will do is right after this stream, I'll be hopping over to our Discord in order to answer any additional questions that you have about tool calling or whatever, life, whatnot. So just go and jump into that Discord. Give me a couple minutes to start up. Just hang out, and we'll be able to answer lots of questions over the next hour. So yeah, okay, and yeah, so I see lots of questions. So bring your questions to the Discord so that we can talk about them there. All right, everyone. Hope to see you in the Discord or in one of our live streams coming up. Bye, everyone.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.